Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. In this video, I will be explaining that how Born-Haber cycle is constructed to calculate uh, any enthalpy change involving in the formation of ionic solid. Let's start. We know that enthalpy change of lattice is equal to delta H formation of ionic solid plus delta H lattice, delta H atomic atomization of lithium of any atom, any metallic atom, plus delta H ionization energy 1 of lithium plus delta H atomization of, let's say, non-metallic atom is fluorine, and it is equal to the half of its bond energy plus delta H electron affinity of fluorine atom, 2 changes into fluoride ion. So if we add the values of these energies, minus 6117 is the delta H formation, 161 atomization of lithium, ionization energy of lithium, first ionization energy of lithium, half of the bond energy of fluorine, which is equal to the delta H atomization of fluorine, and electron affinity of fluorine atom to changes into fluoride ion. So delta H lattice energy is equal to by calculating from here to here, this is equal to plus 432. So we can calculate delta H lattice energy of lithium fluoride is minus 617 minus 432, and this is equal to minus 49. And now let's explain uh, the difference between the, if we use lithium plus charge and lithium plus 1 charge plus 2 charge, and elements carrying plus 1 plus 2 and plus 3. Comparison of these by constructing the cycle. Difference between lithium fluoride and magnesium chloride cycle, Born-Haber cycle. Starting from lithium fluoride, so this is ionic solid. I will be drawing two routes, direct and indirect. So this is direct route, delta H F, it is negative because it is zero down, so the sign will be negative. Directly from lithium solid, then delta H of atomization of lithium from solid to lithium gas. And delta H atomization is always positive, endothermic. Then delta H of atomization of fluorine, which is also positive, and it is equal to half of delta H bond energy. This is fluorine, now changes into gaseous atom. Lithium, also gaseous atom. Next is lithium changes into lithium ion, and it involves delta H ion, first ionization energy of lithium. Signs are very important, state symbols are very important. Now there is another enthalpy change, that is lattice energy. we change fluorine gaseous atom into fluoride ion. First lattice energy, which is always negative, exothermic. So now lithium changes into positive ion in this stage, and fluorine changes into fluoride ion, and these two opposite ions attract each other to form lithium fluoride solid, and it is known as delta H lattice energy. It is also negative because when opposite ions attract each other, large amount of energy is released. So this is direct route. This is indirect route, like so. This is the how to construct the uh, Born-Haber cycle to calculate the lattice energy of lithium. I have explained earlier that how to calculate the lattice energy of lithium fluoride. So we can draw cycle like this. So let's have a look another examples of metallic elements carrying +2 and +3 charge, and non-metallic elements carrying -2 -3 charge. So example 2 is magnesium chloride. This is delta H formation of magnesium chloride. Delta H atomization of magnesium. This is positive endothermic reaction. Delta H atomization is always endothermic. Delta H at delta H ionization energy 1 of magnesium. Changes into magnesium plus 1 gaseous sign and chlorine gaseous. Delta H ionization energy 2, it is always positive endothermic reaction. Magnesium 2 plus gaseous sign plus Cl2 gaseous. Now delta H atomization of chlorine. Into 2, and you know that it is always equal to half of its bond energy. And it is further multiplied with 2 because there are 2 chlorine atoms, so it is multiplied with 2. Next, chlorine gaseous atom changes into chloride ion. It involves delta H lattice energy and it is exothermic. First lattice energy is always exothermic, sign is negative. And it is also multiplied with 2 because 2 chloride ions are formed. Now magnesium ions and chloride ions react with each other to form magnesium chloride, and it involves delta H lattice energy. Solid. So this is how to construct the elements containing 2 positive ions. Now there is another example, that is aluminum oxide. And we know that aluminum carrying 3 positive ion and oxygen carrying 2 negative ion. Let's have a look. Enthalpy change of aluminum atom to form aluminum ion. Aluminum solid changes into aluminum gaseous atom, and it involves delta H atomization The value is, according to data booklet, 326. Then aluminium gaseous atom changes into aluminium plus 1 gaseous ion, and it involves delta H ionization energy, which is equal to 577, which is positive. And this is enthalpy ionization energy 1, first ionization energy. Then aluminium changes into aluminium 2 positive. This is delta involves delta H ionization energy 2, and it is equal to, according to data booklet, 1820. Then changes into aluminium 3 positive ion gaseous, 3 positive gaseous ion, and it involves delta H ionization energy, third ionization energy, and it is equal to plus 2470. Next, enthalpy change. Enthalpy change. Enthalpy changes for oxygen molecule. Gaseous atom. This is oxygen molecule changes into oxygen gaseous atom, delta H atomization, and it is equal to half of its bond energy minus 249 kilojoule mole inverse 1. Now oxygen gaseous atom changes into oxide ion minus 1 ion, and it involves delta H lattice energy 1. It is equal to, according to data booklet, 141 kilojoule mole inverse 1. And oxide ion changes into O2 minus ion, oxygen oxide ion, and it involves delta H lattice energy 2, and it is equal to, this is endothermic, plus 798 kilojoule mole inverse 1. So this is how to construct this cycle. Aluminium oxide, Al2O3 solid, aluminium gaseous, plus next aluminium gaseous, over here solid. Aluminium plus, aluminium 2 plus, aluminium 3 plus. Now aluminium 3 positive plus oxygen 3 gaseous atom, 3 oxygen in gaseous state. Gaseous sign plus -1, two minus. And now aluminium 3 positive in gaseous state, oxide ion in gaseous state react with each other to form aluminium oxide, and it involves lattice energy, enthalpy change of lattice energy Al2O3. Opposite ions react with each other, delta H lattice energy, it is always negative, exothermic. Now let's write down with the other pen. This is delta H formation, which is negative. This is delta H atomization of aluminium. Delta H, it involves delta H ionization energy 1. That aluminium gaseous atom changes into aluminium plus charge. This is delta H ionization energy 2. Changes aluminium to positive. This is delta H ionization energy 3, third ionization energy of aluminium. And this is delta H atomization of oxygen into 3, because 3 oxygen atom. changes into gaseous state. And it is equal to half of its bond energy. Now this is delta H lattice energy, which is negative of oxygen atom, and this is exothermic reaction, negative, and this is delta H lattice energy 2, this is lattice energy 1, this is lattice energy 2, and it is endothermic. And now there's two ions react with each other, two opposite ions react with each other to form aluminum oxide. You know that lattice energy arises, as you know that lattice energy arises from the electrostatic force of attraction of opposite oppositely charged ions when the crystal lattice is formed. So this is all about that how to construct the Born-Haber cycle to calculate the lattice energy of ionic compounds. Be sure to like the video and subscribe. It really helps the channels to grow. Thank you.